Thank you all for coming. I think it's wonderful that we have this size of a crowd to talk about this issue. I hope it's the first of many future conversations. I'd like to first say thanks to Aurelio's, even though nobody from Aurelio's is here right now. Maybe thank them on your way out because they were really generous with providing us this space. I also would like to say thank you to Tri-States Public Radio. Because they have really made a concerted effort recently to focus more on farming, which is a big part of this area. It's a big part of our listenership. They hired me, so that's a big thank you. And we're also doing this series. This is the first of 4. It's called Accents. We're also going to be having like our foraging event where we're going to learn about what kind of foods are in our neighborhoods and in our parks that we can cook up and how to do that. We're going to have a like CSA style event where we, you know how you get so many vegetables and you have no idea what to do with all the food you get. So we're going to try to do like a recipe swap with people who have good ideas about how to manage all of that extra produce. And then we're going to do a farm like storytelling event. So life on the farm, whether you grew up on a farm or your family grew up on a farm or whatever, but those are going to be some of the things that we do down the road. But this is the future of food and drink, how a changing climate, weather patterns are going to impact agriculture in the Midwest. We have a great panel. Before I introduce them, I need to say thank you to these 2 beautiful women because this event would not be possible without them, especially Heather, who is getting her drink. She's wonderful, and this really would not exist without her. So, there was one other thing. Oh, food. We've got some pizzas coming. They're just regular, plain old cheese pizzas. If you want something else besides that, it's going to be on your dime. And drinks, too, if you want a drink. There should be some menus scattered around. There's going to be waiter people coming in and out. And I think that's it. If you have any questions, I want this to be like a really interactive sort of night. So please just raise your hand. I probably will be the one with the microphone running around and giving it to people who have questions. Everybody who's here from Joel's class, I will let him know that there was some people from Joel's class. Appreciate you guys coming. I think he's going to try to come, but he's out planting maybe right now. Can we do like a brief, like how many farmers are in the room? Because it's planting right now, it's like planting time, so like.
The Curtises wanted to be here and they're planting.
Yes.
And
Grant Curtis?
yeah, John Curtis.
John, oh, okay. Yep.
Yeah, they're foot
Different Curtis.
They were very excited about it. It was bad timing for farmers.
I'm taking a gardening workshop with on Saturday.
Tomorrow.
Is anybody going to order? Does anybody want like 5 minutes or something? That was you? No? Should we get started then? No?
Would you announce who we have and who you are?
Who am I?
I didn't catch your name. I know who
I
you
don't
are.
think I gave it.
Yeah.
You know who I am. So I'm Abby Wendell. I'm the agricultural correspondent for Tri-States Public Radio and Harvest Public Media, also known as the girl who wants to ask a lot of questions and take a ride on the tractor. Harvest Public Media, Tri-States recently became part of a network of NPR affiliate stations in the Midwest who are focused on doing reporting about agriculture and life on the farm, kind of rural issues, and ethanol. Yes. Sorry. Yeah, so Tri-States joined that network about 6 months ago when they brought me on board. And we're in Colorado, Missouri, Kansas, Nebraska, and then we've got like a whole slew of people where we don't have reporters, but we've got listeners. So when we produce stories, they go far and wide. We're kind of loosely thought about as sort of the ag desk for NPR proper in DC, which is an honor and wonderful that we've got some reporters in the Midwest who are reaching out to the rest of the country. Welcome, Joel. So who do we have here? Okay, we have Dr. Jim Angel, who is in the center. He is our state climatologist. Yes, we have a state climatologist. Most states do. He's held that post for close to 2 decades. He's based at the University of Illinois. He's worked on a number of research projects and published numerous articles on drought, extreme rainfall, what our climate was like in the 1800s and 1900s, and what it might look like in the future. As the Illinois state climatologist, he works with as many people as he can, students, teachers, homeowners, engineers, farmers, and public officials. To his left, we have Troy Coziahr, which rhymes with desire, which did not work. He is currently the manager of the Learning Center at Monsanto's research farm in just south of Monmouth, where he helps conduct training programs with farmers, salespeople, and extension agents. We're going to hear more about what that means. He has his Bachelor of Science degree in Agricultural Education from Illinois State University and spent about 14 years being a high school ag teacher and an FFA instructor. And he also has his master's in crop science from the University of Illinois. And then we have Adam Wilke or Wilke, okay. Adam is probably had the longest haul. He's coming from Iowa. He's a PhD student in the Department of Sociology at Iowa State University. His research explores the human dimensions of agriculture and natural resource management. For instance, Adam's interested in how farmers make decisions about how to use their land and then how that impacts our rural landscape. I hope I got that right. Adam earned his master's from ISU from the Department of Sociology and the graduate program in sustainable agriculture. Hi, welcome. And so we're going to start off the night with each one of them giving about a 5-minute PowerPoint presentation that explains a little bit more about their perspective. So we're going to start with Dr. Angel. Jim.
Okay. All right.
It's Angel. It's the PowerPoint that's on the desktop.
Oh, okay. That'd be fine. Yeah.
Can everybody hear okay?
So good evening, everybody. Just drove over from Champaign, Illinois, and saw a lot of farmers in the fields. So everybody's up there already, and so it's good after a kind of slow start to the growing season. So, as Abby was saying, I'm the Illinois State Climatologist. I'm located on the campus of the University of Illinois at the Illinois State Water Survey. And probably the ways you might have heard about me was I do a lot of interviews with the Farm Bureau publication Farm Week with Dan Grant. I think I'm on his speed dial. I also do the RFD radio show with Al Duran. I think it's every 4th Tuesday of the month. And then I just think with Todd Gleason at WILL that's like a minute 30-second burst that goes out on a lot of stations, usually on a Saturday morning. So those are some ways you may have heard about me in the past. But so I'm going to talk a little bit about climate change, and just to kind of get the conversation started. So we're not going to, don't scare you, we're not going to do an hour and a half talk on climate change or anything like that. So no test or no quiz. Next slide, please.
Next slide.
So just so we're all kind of on the same page, we talk about global warming and climate change and those kinds of definitions. One of the things we're talking about is with the greenhouse gas. And it's a little bit unfortunate they call it greenhouse gas because really it's heat trapping gases. So actually it's part of our natural atmosphere to have these heat trapping gases in it. We got CO2, we got water vapor, there's a whole list of those kinds of gases. And if they weren't there, we'd be mighty chilly. We'd be about 20 degrees colder than we are right now. So by themselves, they're a good thing. So that's not the problem. The problem is that in the process of burning fossil fuels, we've been putting additional greenhouse gases or heat trapping gases in the atmosphere. And so we're trapping more of that heat. Not a lot, but just enough that it's warming up our atmosphere by a couple of degrees. So that's the kind of the normal process. This is what would usually happen in our atmosphere. And then we're adding to that. And we're also doing some other things in the atmosphere as well. Next slide, please. So this is a plot of global temperatures since 1880 to the present. These blue bars are colder than long-term average. The red bars are warmer than the long-term average. So this is the best we can reconstruct the temperatures of basically the last century or so. So the 1800s, very cold across the world and across Illinois. We had this period here where it was kind of in the middle section, and then we've had the last 30 years a lot of warming that's taking place around the world. And we haven't felt quite as much in Illinois the last year or two, but we have seen warming in Illinois. So it's this part of the record that's been problematic, and that's where we're starting to see the effects of these additional heat trapping gases. So, and here's the plot of CO2 concentration for that same time period. So it's going up and up and up. And really, if this is all that was going to happen to us, we wouldn't have to have too much to worry about. The real problem is that this is expected to continue to grow on. So you burn more fossil fuels and put those into the atmosphere, and we're just going to add more and more to this. So the effects get stronger the farther out you go. So what happens in 2015 won't be that as important as what happens in 2040 or 2095 and so forth. So this is just kind of the thumbnail sketch of what's happening around the world. Next slide, please. So back in Illinois, next slide. So that was global. We'll kind of zoom in on the local here. This is the plot of the average temperature for Illinois. And so we've got pretty good records back to 1895. We've got a few that go back even farther. But this gives us a pretty good picture around the state of what the temperatures are like. And one of the first things you notice is that this blue line is what the year-to-year variability. So there's a lot of variability from year to year in Illinois. It's just a classic middle of the continent climate that we have here, that one year is cold, the next year is warm. They just go back and forth and back and forth. So there's pretty wide spread of about plus or minus 4 degrees from the long-term average. So a lot of variability that you see going along here. And if you could fit a line, we've warmed up about a degree over the last century. So statistically, it's measurable, but for you and I, we probably wouldn't notice it quite as much. And but the more important thing is that we have these wide extremes. So here's 2012, our warmest year on record, thanks to the drought. Here we are in 2014, one of the cooler years on record. So we're almost back to back there. I think if you hit the button a couple of times, it should. Oh, I'm going wrong. Yeah, keep going. So there's 2014, one of the coldest years on record. Keep hitting the buttons there. So the next point I was going to make, though, is it's not just the trends that we need to be concerned about. It's also the fact that we're getting changes in the variability. So there's a period in the 60s, 70s that we're actually, from one year to the next, is remarkably consistent in terms of the temperatures. Not only all across the year, but even the summertime temperatures. One year was pretty much like the last year, etc. And if you hit it, the big bar again, it should highlight this area here. So suddenly in the last 20 or 30 years, not so much that we're getting hotter, but we're just getting a lot more variability. So that captures, the hottest year on record in 2014, the sixth coldest year on record. So a lot more variability in the last 20 years or so. Next slide. This same thing for precipitation. Again, like the temperatures goes up and down one year to the next. in fact, it's very rare for us to have back-to-back dry years, or very rarely get back-to-back wet years. There's a couple times that's happened. Yeah, there you go. Hey, that was a good time. So I had 2 back-to-back wet years there, and then we've had the droughts in 2005 and 2012. And so that's, so there again, a lot of variability from year to year. I think if you click once more, it should highlight, yeah, okay. So this earlier part of the record, we had a lot of drought in Illinois. 1930s, a lot of drought. 1950s were all big drought periods. Very droughty, and through here, more recently, we've had a lot of wetter periods up that part of the record. So we've kind of shifted towards this wetter climate, and about 10% at most stations around Illinois in terms of getting wetter. So we're 10% wetter than we were back in this part of the record. And not only are we getting wetter, but we're seeing more of the heavy rainfall events. So more of the 2, 4, 6-inch rainfall events as well. So it's not just the averages, it's the extremes that are going up as well. Next slide, please. And so just to, and again, this is more of a talking point of where we kind of start thinking about these kind of things. This is, last year they did a national assessment for the U.S. and they looked at a bunch of different models and a bunch of different scenarios. And so this is just one scenario. So these aren't really like a forecast. So this isn't like we're saying, well, this is what's going to happen tomorrow. It's going to be high 72. This is more kind of a what if, kind of like a scenario. If we had a lot of emissions in the future, this is how hot we could get. So we're looking at temperatures on the order of about 4 to 5 degrees warmer across the whole Midwest. And there's even some seasonality to it that's kind of interesting. Winters, summer and fall tend to be very hot, but springtime temperatures maybe not warming up quite as much as the other 3 seasons. We'll see how that plays out. But the main point here is that in all the years I've looked at models, they all have shown warming in Illinois. That part we're pretty darn certain that we're going to see some amount of warming as we move forward. Next slide, please. The precipitation side is a little more questionable. We've got some models showing it could be drier, some showing wetter. This particular scenario shows it's being about 10 to 20% wetter across Illinois, and especially in winter, spring, and fall, and summer could get a little drier. So again, these are kind of probably scenarios in the R forecast, but it does suggest that the wetter conditions we've had in the last 20 or 30 years is kind of expected to continue onward, as are those heavy rain events as we move forward. And some of that actually makes sense physically, because as we warm things up, we tend to get, those tend to be our wetter years. And so in fact, if you go, the other analogy I like to use is, the next slide please, is, okay, pretend like what happens if we warmed up by 4 degrees or 8 degrees, what would our climate look like? Sometimes it's easier to think about it physically. So here we are right now, we're about I use the example here for another talk for Chicago, but here we are about 52 degrees is our average temperature. If we warmed up by 4 degrees, that would put us up down to around Carbondale. Now obviously we live in Carbondale, I've been down there, I've seen it, I know they do. But their climate is a little different than ours. They're a lot wetter than we are. They get more wet, they're much wetter in the winter time. So when we're watching it snow, they're usually watching it rain and getting thunderstorms and such down there. So much wetter, much longer growing season, but then there's other issues that go along with that, different kinds of pests and disease down there as well. So it's not that we wouldn't be able to survive if it got 4 degrees warmer by mid-century, and we'd have to start thinking of ways to do things differently as we move forward. Now another 4 degrees, of course, that puts you down in probably about Tennessee or something like that. So that kind of gives that maybe an easier way to think about when we throw in terms like 4 degrees warmer, what that translates into. And next slide. Oh, okay, so there it is. So here's some contact information. So I'll pass the baton on to the next speaker here. I've got a blog and website. There's my email address. So the blog, I usually post at least once or twice a week on what's going on around the state. So, Troy, okay. Yeah, so I did the one on the new forecast from National Weather Service.
Okay, fine.
So while she's looking for the PowerPoint, again, my name's Coziahr. I work for Monsanto up in Monmouth. What I do is manage what's called the Learning Center. I've got just a quick little slide presentation to tell you a little bit more about the site and what it is that we do. My background is in ag ed. Been in agriculture pretty much all my life. Not really, climate change isn't really my area of expertise. I guess I was asked to come kind of talk a little bit about what we're doing in the crop industry to sort of deal with the conditions that we've got and where we see things going and how we can continue to increase production and provide for the demand that we think is going to be there. So. This is just kind of a shot of the farm. It's a 480-acre research farm. You can go ahead and go to the next slide. There's actually three different groups that share the site. And I guess I should just make sure everybody's aware. So Monsanto is primarily a seed company. Corn and soybean is what we do in this area. That's everybody's obviously familiar with that. But we're also involved in cotton, canola, wheat. We have a fruit and vegetable seed division called Seminus, so all different sorts of fruits and vegetables, and alfalfa for forage crops, the list goes on. Obviously, in this part of the world, corn and soybean is the main focus. We do have some other learning centers across the U.S. There's actually 4 learning centers. There is one out in Gothenburg, Nebraska. Their main focus is drought and water utilization. Water use efficiency, irrigation technologies, that type of thing. There is a new learning center that we've just opened in Huxley, Iowa. Their main focus is information technologies, data science. That's really what they're mainly focusing on. Monmouth was the first learning center. Our main focus is really high-yield corn and soybean systems. And then we've got one down in Scott, Mississippi, and their main focus is cotton. But of course, there's overlap between all 4 of the sites. So, but at the Monmouth facility, like I said, there's 3 different groups. We have a breeding group, a corn, and he's entirely a corn breeder. Obviously, we have soybean breeders, vegetable breeders, and so on. But at Monmouth, we only have a corn breeding group. And they are, traditional breeding and using some new technologies that we'll probably talk about a little bit later tonight. But basically, they're doing corn breeding as we think of corn breeding, taking pollen from this line and crossing it with this line, and ultimately creating new inbreds, new parent lines, and continuing to improve stress tolerance and productivity levels and things like that. So they are responsible for creating the new hybrids that will eventually make it to market. Then we have a group called Trait Field Solutions. So in addition to being a seed and breeding company, Monsanto, obviously the one that most people know about is the biotech side, right? And so Trait Field Solutions is a group that works with the biotech side, the new traits that we're working on. They work on getting those new traits, breeding them into some of the new lines, the new inbreds, test for effectiveness. They're basically working on our pipeline. The stuff that's anywhere from 2 to 10 years away from coming to market, they're working on that right now, and they're generating the data on those projects and helping us see which projects are going to be more productive. And then you've got the Learning Center. This is the group that I manage, and our main job is really education and outreach. We put out we don't do a lot of scientific research necessarily. We do some. A lot of what we're doing is demonstrations. We try to take the research that's being done in the industry and try to represent it visually in demos. I've got a picture of a demo you'll see in just a little bit. But basically, so what we do is we try to put together these trials and these demonstrations, and then we host farm tours, and we also host trainings. And those trainings are typically, people within the company, people with other companies that we deal with. Company hires new salespeople, they'll come and get agronomic training at Monmouth. If we have a new product launch, we'll typically do a lot of that product training and that type of thing. The groups that come through the site they run the gamut. Mostly it's farmers and seed dealers, but it's also high school kids, college kids, Cub Scouts, legislators, investors, people that just want to learn more about agriculture, academics. I mean, it runs the gamut. A lot of international visitors, mostly from South America, but really from all over the world. If you add it all up, between 5,000 and 7,000 people a year come through the Monmouth Learning Center for tours and training. It's a lot of people. It's really, for somebody like me with a background in ag education, it's a fun job. I really enjoy it. I get to play a lot and try to put together some interesting visual demos and talk about some of the research that's being done in the industry. So I enjoy that. Next slide. This just I'm not going to go through all of this. This is just some more information about the site. There's kind of an overhead view of it. We're very fortunate to have some nice flat, black, deep, fertile soils in the area. We do have irrigation available across the farm. Very seldom do we ever use it, as most of you know. Out west they put pipes in the fields to take water in this part of the country. We put pipes in the field to take water out. As a matter of fact, we just had the entire farm tiled on 20-foot centers. So if you could go back just real quick. I guess I've already talked about this. There's about not quite 40 people full-time working there, and then we bring in a seasonal staff of over 100 people. Most of those work for the breeding group. They do about 100,000 hand pollinations every year. That takes a lot of hands, and so they bring in a lot of people. I myself usually hire 4 college interns. I know there's some college students, ag college students here. If you're looking for an internship opportunity, why keep us in mind? And I've already got everybody for this summer, but keep us in mind. We do look for good people every year. So go ahead and go to the next slide. This is just some of the key topics that we talked about with farmers last year. A lot of them are going to be similar this year. High yield systems, how to manage pests and things like that. Some of the newer information technologies, data science, that type of thing. Cover crop systems is something that's becoming more and more popular in this area. There's a lot more interest in it, and so we're doing some work there. And just like I said, we deal with whatever Mother Nature's throwing at us at the time. And so as people come through, early season issues, if we've got disease problems, well, that's what we talk about. If we've got drought issues, or if we've got too much water, or whatever the case is, we've got demos out there to help talk through that. Next slide. This is just, we might refer back to this a little bit later, I don't know. This is just a 100-year representation of the U.S. average corn yields in this trend line here. And they didn't start until the 1920s. They really didn't start tracking soybean yields. So this is bushels per acre there on the left. So we can talk maybe a little bit later on. We can talk specifically about what some of these different sections in the graph means. But this is one way to look at it. The next slide, I think, is kind of a neat way to visualize it. This is something we put together a few years ago. We call this our biological bar graph. So this is just strips of corn. We also have one for soybeans as well. But if you look, so for example, this bar right here is 20 feet wide by about 73 feet long. This is how much land was required to produce 1 bushel in the early 1900s. And as you move on, the strips get narrower and they get shorter. This is a little bit, we need to up this. Again, we're talking U.S. averages. Last year we were over 170 bushels, so we probably need to up this a little bit. Very common in Illinois to see these types of numbers, but we're going from an area that was 20 foot by over 70 foot to an area that's 10 foot by less than 20 foot to make that same bushel. And so that's really what all of this is about, and I think really what some of this discussion is going to be about tonight is doing more with less. So it's what we're trying to do. Just real quick, I was going to bring the other slides up later if we needed them, but just to give you an idea of some of the things that we're doing. This is kind of another way to look at this. Go ahead and go to the next slide. This is a demo that we did last year looking at. So we took an old early 1900s corn variety, a 1970s corn hybrid, and a modern day corn hybrid. And we planted them at 3 different planting populations. 16,000 plants per acre, that's kind of more of a 1930s plant population probably. 28,000, that's more of a kind of a late 1900s plant population, somewhere around the 1980s, 1990s. And then 40,000, which is a little bit, that's above average. You know, today is probably around 34,000 plants per acre. So we're stressing the plants out a little bit. And it's kind of neat. You can see when we go back to when we give the plants a lot of breathing room, you know, there's obviously the modern day hybrid still does very well, but there's not a heck of a lot of difference between those. And as you put more and more and more stress on those plants, these modern day hybrids, this is where they really shine, and that's the advantages that we're seeing today with these modern hybrids. And we'll probably get into some of the reasons for that. And I think there's one more slide on here that is just a visual representation. So here's that early 1900s variety at 6. This was 5 consecutive. Actually, it wasn't 5 consecutive years because some of the plants were blank. They didn't produce ears. But I just went through and got 5 years in a row at 16,000 and 5 ears at 40,000. And I did that for the early 1900s, the 1970s, and the modern day hybrid. So when you look at the stress tolerance levels and the agronomic health of that modern day hybrid, you really see where a lot of that productivity is coming from. So I enjoy doing things like this. It's kind of fun to try to come up with visual ways to look at and represent some of the things that we're doing in the industry. So I think that's it. We'll go one more. I don't think I had any more slides over here. That's the last one? Okay, so that's all I've got. You know, we've got some college kids in here. Let me, before we move on, just invite anyone, if anyone wants to come visit the site, you know, contact us. I've got cards here tonight. That's what we do. If you'd like to come up for a tour and see what we're doing, let us know. Get a hold of us, and we'll be happy to host you. Thank you.
Hi there, everybody. How's the pizza? My name's Adam Wilke. I'm a graduate student at Iowa State University in the Department of Sociology, and I'm very interested in how people receive scientific information about climate and both about agricultural science, and why or why not they might implement that science into their decision-making process as they make agricultural management decisions on the landscape. So I thought beliefs, talking about beliefs and how people make decisions would be a nice complement to the presentations on climate science and agricultural technologies, but I thought it'd be fun to start off with sort of an interactive thing here. So I'll give you a moment to sort of read through this question, and then I'll go through and ask by a show of hands how many people in this room right now would fall into each of these categories, and then we can sort of use this to color the conversation here as we move forward. So thinking about the question, please select the statement that best reflects your beliefs about climate change. Climate change is occurring and it is caused mostly by human activities. So, quick count,
That's better than...
yeah, so that's about 26. Okay, that's a good showing. Second here, climate change is occurring and is caused more or less equally by natural changes in the environment and human activities. All right, 5 there. Climate change is occurring and is caused mostly by natural changes in the environment. Be brave. Okay, 0 there. There is not sufficient evidence to know with certainty whether climate change is occurring or not. That one's really interesting to think about. Is anyone gonna raise their hand for that one?
Oh, well.
Okay, good. 1. Okay, some days I'm with you.
No.
Okay, 5. Climate change is not occurring. Okay, 0
Does every
there.
day.
Yep. Next slide, please. So once again, Adam Wilke, thinking about farmer perspectives on climate change. So we understand science is a body of knowledge, but science is also a process. So how do we use science as a body of knowledge and as it evolves to help inform our decision making to produce food for our growing society? So next slide, please. I'd like to say I'm part of a much larger project, the Cropping Systems Coordinated Agricultural Project, commonly known as Sustainable Corn, based out of Iowa State University, but a group of much larger land-grant universities. Also have some private industries involved and state and federal agencies, so it's a really neat, interactive, interdisciplinary project representing people from agronomic scientists to economists to social scientists. And we're looking at a suite of practices, first being cover crops. So as you heard from Troy, there's a lot of interest in cover crops right now, and that's sort of driving a lot of really great research that's showing some really neat things. Secondly, being nitrogen management. We understand there's some conversations right now in nitrogen use on the landscape. Third being tillage management. So there's a lot of ways to do tillage on the landscape, and so some scientific investigation is helping guide producers in how they make tillage decisions. And then fourth being drainage water management. So there's some neat techniques where you can filter water as it comes out of drainage tiles and other things. And then fifth being extended rotations, crop rotations. And that's a neat one to think about sort of the time perspective of rotations. When you're growing corn and soybeans and you're gathering scientific data, you can have a data point every 2 years, but if you're doing 4, 5, or 7 year rotations, it takes you that long to gain a data point. So it's a long-term project represented in these states here. So gathering data at a bunch of different sites affiliated with the long-term ecological research trials. So some really neat data. Next slide, please. But what we do as sociologists and what we're interested in is how is this advancing agronomic science actually communicated through channels and implemented upon the landscape. So scientists can develop some really neat things, and things are being developed every single season as we advance knowledge within the Midwest. But I'm wondering, how do they actually get communicated both through networks and sort of coffee shop talks and formal networks such as extension programming and those types of different things. Monsanto and other private industries are being very active in communicating information to farmers, and that's really great, and it is changing a lot of decision making on the landscape as we drive around now and we see things like cover crops that we may have not seen just 5 years ago. So next slide. So in 2010, just prior to the drought of 2010, we implemented a survey to almost 5,000 farmers across that region. And these were the results that we got back. So sort of thinking about the response in this room and how it might be similar to or contrast with some of the different responses we see on here. So you can see here that less than 10% of the farmers that we surveyed in our sample think that climate change is caused mostly by human activities. And something that I'm really interested in thinking about science communication is 31%, almost a third of the farmers in the sample believe that there's not sufficient evidence to know with certainty whether climate change is occurring or not. And so that's really interested in light of all the modern advances in climate meteorological sciences and still this sort of skepticism within the agricultural community. Next slide, please. So this sort of just teases out the statistics a little bit and exemplifies that 2/3 of the sample do believe that climate change is occurring, and 41% believe that humans are at least partially responsible. So there is some receptivity that these changes are going on. This same question has been implemented in a bunch of different surveys, and it's kind of neat to compare these different groups. Because thinking about humans embedded in these social systems, we sort of react our decisions upon the people that we reference within our local communities. So comparing these numbers here between farmers, ag advisors who we're finding are very trusted by farmers in receiving information. So for example, seed dealers and those types of things. While extension educators we're finding falling in trust because historically there's been an extension educator in every county, while now those offices are being consolidated, so extension educators, less and less so, are actually embedded within the communities of the farmers. Climatologists, it was a small sample of 19 climatologists across the north central region, but more than half believe that climate change is occurring. So just to point out again, astonishingly, the farmers are the most skeptical about the scientific evidence about the sufficiency of certainty of climate change occurring. This is the last slide. One more point. And this is. Oh, go ahead. This is really interesting to think about. We understand there's a precipitation gradient. So Nebraska will get 10 to 20 inches of precipitation perhaps per season. And as we go eastward, we see a lot more precipitation. And so asking about concerns of more frequent events, you can sort of see these feedback loops in this part of the Midwest has experienced more frequent and extreme precipitation events compared to the western side. And so that's actually reflected in their concern about the frequent rain events. I think that's all I have. Here's some resources you can look up and email me if you have any questions. And I think we had a